everyone? I guess that was kind of the alarm for the class starting. How's everyone doing? You're all right? Yeah. Thriving, surviving, somewhere in between. So we'll take attendance. You want to have an attendance question idea? And while I'm doing that, you can pass your work to Mary Cooper. What all are we doing? This will be lab reports and on your own questions. And some of you have already turned those in, but all right. Yeah. I was actually just thinking that. That's so weird. Yeah, I was literally just thinking that, and it was like, where'd that come from? Okay, favorite theme park. Annalise. Okay, which one? Like the main Magic Kingdom or whatever it's called.
I'm gonna go with Universal, even though I've never been, but my siblings have gone, and I mean they have Hogwarts, so I mean like how could it not be epic?
It is.
Bryson.
I don't really do theme parks.
So, what would you do in place of the theme park? Sounds good. All right, Caitlin. Nice. That or SeaWorld would be my answer, but okay. Yeah. So, and Dylan. Busch Gardens.
Oh.
What's Busch Garden?
Oh, I've been there.
Jake. Universal. I've actually never been to Universal. James.
I like Universal and Disney. If I were to choose, I'd probably choose Disney.
Really?
I hate
Yeah,
it.
we've been to Disney with me.
Kate. Disney.
Mary
Caitlin.
Definitely Universal, like the Harry Potter section, because I wonder when I was like obsessed with Harry Potter, so I was completely nerding out about it. It's great.
And Rory's out. Pray for them. Their dog got hit by a car, so I know that's really sad.
Wait, what?
Her dog died?
Yeah.
Which one?
Athena. Yeah, Athena's like they've had her for 13 years. So, Sarah.
I don't know. I've been to several parks, but I don't remember all of their names. The only thing I would pick is probably Disney World, but it's very boring, you know. Have you been to
And Basil.
what? You've been to you know,
Oh, Dolly.
I know of Dolly World. I've never been there.
They got a bunch of them.
Nice.
I don't know.
Now, you guys are probably a lot of you probably been to Wild Adventures, right?
Yes.
So we had an end of the year class trip there when I was in 9th grade, and we had to be in groups, and so I was with the only two other boys in the class. The names were Matthew and Morris, and so we decided it was really they decided, and I was kind of dragged into it. You know the ride Pharaoh's Furious? It's like a pharaoh boat. I guess it's got like a masthead of like a pharaoh, and it's just a pendulum that goes back and forth. They decided to ride that 13 times.
I wouldn't mind that. That was my favorite ride.
Yeah.
And
Just make sure you don't eat anything.
but they were what it was that they saw that the ride operator who they decided reminded them of John Goodman, kind of looked like the actor John Goodman, but he really did actually. But he just like seemed like he was just really ticked off, not having a very good day. And so Matthew and Morris decided that they would ride it 13 times to annoy him. and so they were like, we we made up this Pharaoh's Fury theme song that they were just like screaming at the top of their lungs while we were riding, like Pharaoh's Fury, Pharaoh's Fury, Pharaoh's Fury. It's like being really obnoxious, and all the people riding with us would just laugh and have a great time with the ride operator would just be like. So by maybe like the seventh time or so, I stopped writing it, but they just kept going over and over and over again. All right, so we got a couple experiments we can do today. No lab reports required, but let's open up to experiment 4.6. Let's start with that. 4.6. So this one's not going to work that well because we don't have like an ideal glass surface, but you'll be able to see a little bit. So this is relatively flat and smooth. Let's see if I can find a flatter, smoother one. Maybe that's smoother enough. Or yeah.
Is this time being on the board?
Yeah.
Yeah. So I can actually pass these around. Yeah. All right. So you can take, I don't know, maybe this one.
So we're not doing lab report on anything.
Nope, just for fun.
That can be extra credits.
I'm holding my breath in case any of you are worried about that. And we actually have a jar per table. Look at that.
No way, we have to get it.
But what we're going to do in the experiment is first, you're just going to pour a little bit of water on the glass. And this is slightly warm water. It's actually warm for the other experiment. Yes.
How thoroughly washed was that? We use it as a source of air.
Yeah, that would be, I don't know.
No,
Sarah prepared it, but what's, yeah, I don't know. I really don't know. Sarah did it, so she probably washed it well. I like Sarah. So she's very nice. But yes. Everyone just like stopped. Hear that. So we're going to be observing how water reacts with the surface of the glass in two situations. The first one, we're just going to put the water directly on the glass, and I'll do this for the camera. It's not going to be that exciting for the camera, probably.
We're just pouring water on the glass.
Yep. That's step one, anyway.
Physical.
So you can pass this around and do that. Go ahead and just pour it on the glass and just look how it behaves. Now notice. Yeah, and notice that, and you could do that, but also maybe pour a little bit on the side and let it run off. I'd recommend that. So it just kind of pools, makes a puddle.
How much?
Oh, dang it, that's not good. I just.
How much?
It doesn't have to be much.
That good? Very solid. Much. I'll give them toilet paper first. I'll give it. I was doing the paper because it's good.
So let me know when you've all had a chance to do that. Pour some on the side and let it run off, as well as pour it on the top and let it cool. And let me know when you've all done that.
And you made it run on the side. For your math.
All right, everyone good? Everyone done? All right, so now the next step, what you're going to do is, and sorry, I guess I didn't give you the last table one because I have this demonstration one. The next step is take the candle and you're just going to rub it maybe a little bit on the top, a little bit on the side. I'm not going to do the side here. And then pour water on the top, see how it behaves, if it behaves any differently. Then pour water on the side and see if when it's running off, it behaves any differently.
Yeah.
Alright.
Supposed to wake it up.
Yeah, wipe the water off.
Okay.
And I'll grab this. Yeah, so I'm not seeing any difference on the top because it's just enough water that's cooling. Actually, if you get it to be just a little bit of water, you can see a difference.
Do we want to take the side now?
Yeah, so top and side. You can kind of see a bit of a difference there. See how it's not really as pooled where the maybe push the water around on top of the wax too. See if it behaves in a funny way when you push it on top of the wax. Like just get a small amount and do it around.
What's supposed to happen?
If you have enough water, it's going to look the same. It'll just be a big puddle. But if you have a small amount of water, like even try something like this, maybe you can actually just kind of push it around on the wax and see how it acts.
What was supposed to do? What was supposed to happen?
Yeah, you can
It dried up.
see. There's not a paper towel in this room. They didn't. Yeah, they were supposed to have paper towels and. Hey, actually, I found some. We're always supposed to have paper towels in the spray bottle, but
No, I already did.
Somebody wants this candle, you can have it for this. You guys can have this. So I noticed something when I was doing it. Anyone noticing anything?
The water does not like to be
Yeah, it doesn't like to be on the wax. So what does it do? Yeah, it goes away from it. And it does so in a particular way. When the water's just on the glass, and the best way to do this experiment, like I said, it's not the best results here. It would be if we had like a flat pane of glass. But since we just have, far from flat jars, we're just making the best of it. But yeah, the wax. If you were to guess, do you think wax is polar, non-polar, or ionic? Non-polar. Why? Yes, very good. Because remember, since water is a polar molecule, as I said at the beginning of this module, everything about water makes sense if you understand its polarity. Positive side, negative side. And if you have a polar substance, you can have like something with a positive side or negative side. I guess I'll just draw more water. Attracted to the positive or negative side, whatever the opposite is of the water molecule. If you have something ionic, that would be like, say a positive sodium getting attracted to the negative side, or like a negative chloride getting attracted to the positive side. But then if you have non-polar, it's just not going to react to the water because it's not charged. Or another way to say this, the water will not be attracted to it. So if the water is on the glass and it's actually going to be more attracted to the glass than to the wax because the wax is non-polar. And so it's going to just kind of spread out across the glass and stick to it a little bit. But then when we put it on the wax, is water more attracted to wax or to itself? Itself, yes, because remember, water is polar. So one water molecule will attach to the other. And what do you call it when they get as close as possible due to that attraction? Very good, hydrogen bond. So yeah, that's why when you put the water on the wax, didn't it bead up? And again, you want to have like if you just basically saw a puddle the first time and a puddle the second time, use less water the second time. Like maybe just get some of the water off. And if you have a very small amount of water, you can actually end up with a bead or two of water that you can push around with your finger and it'll stay as a bead. Try that out if you haven't. So have your parents ever bought like some kind of something to mix with their wiper fluid in their car that makes your windshield like more like protected from the rain?
It like when we do the car washes, it's an option for the water to heat up.
Yeah, that would be it. Yeah. So yeah, sure. So basically, that's what's going on is like you're mixing in something non-polar. And if you have a car wax and you ever like wax and then clean your car, you'll notice that the water like really beads up on it because it's it's a water resistant material. Yes. Sure. When you have something that's water resistant like that, one thing you could call it is hydrophobic. That's just a fun term.
Oh, actually, like
And there's a lot of animals that utilize this, like they'll create some kind of an oil or something that will cause them to be waterproof. It's really fascinating because like, well, you've ever seen, like, you've probably seen water roll off of like a duck's back, like their feathers are waterproof. And there's a lot of animals that are thoroughly waterproof. And if they actually weren't waterproof, then if the water actually got into their fur or their feathers, they would drown, or they would, freeze if they were in cold water. So yeah, being hydrophobic, having that quality is actually really important to a lot of animals. I think one of the animals, maybe that, well, no, I don't want to say that unless I can remember for sure. But then there's a kind of a bird locally that is not, it doesn't have that ability, doesn't have the right oils on its feathers, and so it's not waterproof. Do you guys know what that bird is? I'm thinking like something you'll find around, maybe, but something you'll find in lakes. Okay, so yeah, maybe that's true for them too. Not thinking of crane.
No.
Of what?
I just said,
Oh, no, not a duck. You'll see them like sunning themselves, stretching out their wings.
oh,
see?
Yeah.
Those black birds.
Yeah, the anhingas, I believe, right? I always confuse them with cormorants. They can also be called snake birds, but yeah, anhingas, they have to dive to catch fish, and every time they dive, they get wet, so they have to get out of the water and sun themselves, and it's kind of an inefficient way to live, I suppose. But other birds, with the hydrophobic feathers, they just go in, and because of the wax on their feathers, or the oil or whatever it is, like they just go in, they go out, and they're dry.
So we could put this something with their feathers.
Yeah, I mean, if you can get something like that, and whatever it is, it would have to be something that doesn't like mess with their flight. I actually almost pet one once, but as I got really close to it, I noticed his beak looked incredibly sharp, and so and he was getting a little perturbed, like as I got close to him, he started like trying to intimidate me, but not surprised. So you shouldn't do this, but have any of you ever tried to catch a duck at Lake Ella? Please don't do this.
I'm trying to catch a duck.
There's
It
reasons
never
not
works,
to,
so you
but
run
I'm
away.
just curious how many of you have given into the temptation. I've tried to like pluck a feather from one's back before, but I don't know. Somehow they always do it. But it was only because the feather was sticking out, like it was already loose, So yeah, they are. I
Don't
think.
be afraid when you start running at them, maybe.
I'm pretty sure if you ever like, again, don't do this. Like, I'm hesitant to even say this, but I'm pretty sure if you wanted to catch a bird like that or a seagull or something, if you like lay down, cover yourself in a blanket, and put bread on the blanket, I think you could just like.
Don't try and stuff.
I don't know for sure though. I've never done it, but
Never.
I've done that to my dog. You know, my dog Fudge, who we had a long time ago. But anyways, so and I can actually if we end up with enough time to kill, I might even show some videos about different animals that utilize this in surface tension because it's really interesting. In fact, you know what? What if we do that? You guys want to see a video?
Yeah.
Now it's going to be on this, so it's going to be a small screen. You still okay with that?
Yeah.
All right. Yeah, just get your masks and huddle, I suppose. Yeah, I don't really. I mean, I probably could, but
You just push that button and then you take the gray remote right there, like on.
so what kind of where do I plug in those? Is it that thing? The blue one?
Yes, I believe. So.
Let's see if I have a port that works. If I do, then yeah, this would be a good thing to learn. All right, hold please. Those online, if
Yeah.
anybody is online right now.
We got like one of those. I think
It's
the
that
second one.
gray remote.
Hey, look, it fits.
We have to grab the another one.
All right, so that's plugged in. If this takes me more than like 3 minutes, I'm just gonna bail and just show it to you on the laptop. But I do want to learn.
And then you push.
Press the button. Press the wait. Press that.
Well, I mean.
Okay, I think that light just turned green. And I see a light coming through. Can somebody kill the lights there? Don't need no light either way. Maybe I.
Right there.
Hey, look at that. Okay.
And then
Maybe if I hit computer, so it's just loading and then it'll actually show once it.
I believe
So this means if anybody's ever zooming in, we can just have them like
on
display
the
it.
Yeah. It should be computer input.
Yeah.
So is that computer? Yes, it is. So I'll hit enter. It says no signal. So okay, I see there. That was also.
Wait. Is it- I think we're making something. Yeah, yeah.
Is it something with one of those shorter cables up there?
Yeah.
It's probably a volume one. Because I do see here's an audio cable. Because I see two cables. There's the DVD ones. Yeah, so that stuff connects to the DVD player, I believe. This is an audio one, but I'll go ahead and just do that. So that way sound will come.
See the short ones on the wall?
That's something fun.
Yeah, see the second one.
Please.
Yeah, so, yeah, he uses one of those.
So these are just extension things.
Or like.
Oh,
it's probably
but if
because
you're
his
doing that-
computer doesn't have
Oh.
Okay. Okay, yeah, they're adapters. Yeah, so mine actually did go in directly, so I don't know why it's not cooperating. It could be a display setting.
Well, this picture right here does come up when he does it. Yeah.
Okay. Yeah, so on computer one, no signal. So the second one doesn't say no signal though, so I'm gonna go there. It says input.
Yeah,
Oh, it says no signal. So the last thing I'm gonna try. Wait, it says network. What is that about? I already went there, I guess, but this actually does say something. All right, so I'm gonna try one more thing, which is the display settings on my laptop. Yeah.
Oh, do you have to do the S thing?
Yeah, the F buttons maybe. Here we go, F8. Let's see if that will cooperate. Maybe shift and F8. I don't usually use these on this computer.
Full screen button.
So I'll go to display. If this doesn't work, then don't worry about it. We'll just. Okay, yeah. I think I give up. Is that all right? All right. Well, thanks for trying. I appreciate it.
Oh, yeah, you also have to
There's
look
one
at
last
twice.
thing. If I hit computer, that just goes to these. Okay, never mind. Have to hit what twice?
The off button tries to turn it off.
Okay, thanks.
Yeah.
All right. Okay, well, it was worth trying. Okay, so now I'll just move it over there, and you guys will hopefully be able to see it. I wonder too if maybe the fact that I have my camera on messed anything up. Probably not, but anyway. But I got to record, so all right. Pull up. First video, I'm going to show you a very waterproof gecko. He's like very waterproof. Put this on, can I do screen share? Yeah, here we go. Yeah. All right. There's not much volume. Like it's just a really quiet computer. But they say this gecko can fit on a fingertip.
But it's so nimble, it can escape from the hunting monsters of the underground.
So look how small it is compared to a beetle. He's the world's smallest gecko, if I remember correctly. And what they're going to explain is because he's so small,
That it has special problems with, for example, rain.
that it has problems with rain. That's just one rain drop. Yeah. Yeah, how'd you like to?
But its skin is hydrophobic.
Its skin is hydrophobic. See that bead?
Cannot wet it.
So that's what's happening on a small scale when with the candle wax.
You might think would risk death by drowning.
Oh, is this that gecko that runs?
No, I'll show you that one too. But he just floats.
Is unsuitable.
Wow.
He's unsinkable. See that?
It's so light and its skin so water repellent that it can literally stand on water.
It's so light and the skin is so water repellent that it can literally stand on water.
Oh.
All right, so now I'll show you the one that can run on water. But this is a larger lizard. He's going to be doing something different.
He's crazy.
Yeah, this one is called a basilisk.
Wow, crap.
And I apologize for you know, any ads that may or may not appear on the Zoom thing. You know, I can't really control that. Oops, why did that go away? All right, here we go. I'll do that again. Yeah, phone away, please. It's a MailChimp commercial. We're getting a lot of those lately.
If you want to make your emails highly personal, insert things like your customer's name, birthday, or
There we go. This is a larger lizard. He's like iguana-sized almost. Well, it's a series called Words Dead Base. This is in Costa Rica.
Speed is everything for the basilisk lizard.
Speed is everything for the basilisk lizard. No, I don't
Prey
think so.
on winged insects.
They prey on
You
winged
need to
insects,
be quick,
so they need to be quick
because your prey moves fast.
because their prey moves
really
fast, really fast.
So when the basilisk is in a hurry, it displays one of the most spectacular capabilities in nature.
So when a basilisk is in a hurry, it displays one of the most spectacular capabilities in nature.
This flat-footed reptile is so fast and so light that it can run across the surface of the water at speeds as much as 5 feet per second.
It's because of the surface tension. So he's pushing at the right angles to counteract his force on the water, so he doesn't push through. He instead just pushes off.
Doesn't make this superpower possible. Long toes on their rear feet, along with fringes of skin that unfurl to meet the water, create little air pockets under the lizard's feet.
It creates
And
little
the
air pockets under
make
its
the
feet,
lizard lift.
which will give it lift.
A true superpower in nature.
You want to see some more stuff like this? All right.
Great. This is the best science class ever.
Might be able to do this more often. I do have videos for like pretty much every module, but this one I just couldn't resist. I got another basilisk video, but I think I'm going to skip that for now. This one's kind of similar. This is just another, this is actually a bird that utilizes surface tension. Another male chimp.
If you want an email
But this one's not quite as amazing as that. It's just interesting to see.
parts of the world, use Time Warp.
This is called the Clark's grebe. Kind of like, what was his name? Becky from Finding Nemo 2.
Yeah.
Join together to review that package.
Oh, Red Eyes.
Yeah, that's why I say that. You know, I don't know. I don't know.
Why does he have big eyebrows?
Isn't that crazy looking? Uh-huh. I love just the spray of water around him too. Mhm. Mhm. So yeah, they're just it's not as crazy as the physics behind the basilisk, but they are utilizing water's surface tension to stay above it, you know. So let's find. I also have this is the example from the book, the water strider. And this is like the pygmy gecko. It can just kind of walk around on the water or stand on it. I hope this video has that. I can't remember if it does.
I was really intrigued to see that.
Yeah. So that's the water strider. He looks spiderish.
Water striders are almost magical.
But yeah,
I
see how
mean,
he's just.
come on, they're literally walking on water. But come down to their level, and it's a bit more sinister. These delicate little bugs have figured out how to master the elements.
You can see the water
and to
bending
exploit those
underneath each of the feet. And see how it's like a rowboat.
So how do water striders float where others sink? The answer is those crazy long legs. Water is pretty sticky stuff. It likes to hold on to itself. It sticks together especially well right at the surface. If you're small, it can actually hold you up, as long as you don't break through that surface tension. It seems like the water strider's legs would just sink right in, but they don't. They make dimples on the surface. That's because their legs are covered in tiny hairs called microcephaly that repel water.
So hydrophobic
The
hairs are what
strider's
keep it up.
entire body is covered in them. Those hairs trap a layer of air that keeps the water from sticking to its body. The water strider simply can't get wet. That's how they can sit on top of the water without breaking through. Plus, they're pretty light, and they spread out their weight with their front and back legs. They use their middle pair of legs to maneuver by pressing down and back against those dimples, just like rowing a boat. They can even catch some air. Most of their fellow insects aren't quite as graceful. Like this caddisfly, struggle as it may, it's stuck, half drowned. Exactly what the water strider has been waiting for. It probes for a weak spot.
Censored.
And pierces through, spitting digestive enzymes in that dissolve its victim from the inside. Then the striders take their time, sucking out the innards,
It's interesting
leaving
that
the
they actually.
caddisfly a dried out husk.
It's interesting that several of them came.
The stream delivers an endless buffet of new victims. Because for most, that razor-thin line between water and air is a treacherous place. But water striders know. Keep your feet dry, and you'll always have the upper hand. Hey there, it's
So yeah,
Lauren.
unfortunately, it
I
didn't
know
have
you see that
the
subscribe
whirly
button
gigs
there.
with the detergent,
Here's what it'll get you.
but
New Deep Look episodes
that is something
every
I would imagine you could probably look up. Yeah, so it's interesting. There are a lot of insects that just like squirt digestive juices into their prey like that. It's not very pleasant, I suppose.
It was like so strong compared to that.
Yeah. All right, so I think I'll stop there with these, except if we have a little bit of time at the end, I have one more video that's just kind of totally for fun, but could be tied into another module as well. All right, so I'll end the screen share. I actually need to plug in real quick. If someone could get the light, that'd be great. We got one other experiment we can do. And this one's, you know, this is one that you've probably kind of seen happen before. We're going to take a bunch of different substances and test how water will dissolve them. So you can keep your jars. We could keep them one per table, just for the heck of it. And you're each going to get water and a different substance to dissolve in the water. So what do we call something that dissolves something else? A solvent, yeah. Another thing that gets dissolved is the solvent. So solvent, that dissolves. Solute, it gets dissolved. Can anyone think up a memory trick for that? So I want you guys to miss 2 points on your matching or your fill in the blank section on the test. Here's that. The ideas. What's that? Dissolve. Oh yeah, very good. So dissolve, the verb of actually dissolve, it's got that V like solvent as opposed to solute. That's good. All right. So this is experiment 4.3, I believe. Let's find out. There we go. So we need 5 glasses. We have a bunch of stirring spoons, which we have. I guess we don't have that many, but you can pass them around. And each table will get something different. Sugar, try not to make that, try to get that on the least. Check this, I guess. So, and I can't remember if these are actually supposed to go together or if they're supposed to be separate tables. So now let's do separate tables. Olive oil. Olive oil is very, very green. Yep. Okay, so someone can start reading the instructions for experiment 4.5. No lab report is needed. Okay, so fill this 4 of the glasses 3/4 full of warm water. So that's our warm water. And maybe back table, you can get a different one.
Yeah.
Yeah, here.
Camera's out of focus. Doesn't really matter, I suppose, at the moment.
Who makes a sound?
All right, you can just pass that around, except to them.
Did you have? Who makes a sound? You have to be-
Why is it behaving that way?
Do we start dissolving stuff?
We'll follow the instructions, which are, I guess the next one, it says to put a certain amount of that in something. We'll do them one at a time.
Got it?
It says 3/4 full, right?
Yeah.
Okay, what's the next step?
Measure out 1/2 teaspoon sugar, mix with water.
Okay, so you guys can do it first, and if you want to do it in front of the camera, that'd be great. But where the rest of the class can see, you can pour in the water or the
Sugar?
sugar, yeah. And it said, how much sugar? 1/2 teaspoon, right? 1/2 teaspoon. There's the measuring cup in here. It is a 1/2 teaspoon. Did it say stir? I can't remember.
Well, too late.
And mix with the water.
Okay. You want to do that in front of the? I guess I can just turn the camera or move this or this table. Yeah. So we got the sugar in there, and you've all done this before, right? So, yeah. What do you think you're going to see?
Is that? I can't tell if it looks like it's.
Yep. And so it'll take some time before it's completely dissolved, but you can keep stirring if you want. All right, now same thing with salt. 1/2 teaspoon.
I have to dang it. So much.
Maybe you can pour it out of the scoop. That'll get the sugar out of it. Yep. And would you mind doing it up here too? Thank you. It's not over the laptop. I already made that mistake.
Ready to pour?
So, well, you could pour it over the measuring spoon over there, like pour it into the measuring spoon so the measuring spoon's full. Well, I said not to scoop it. And you can pour it over the spoon. Yeah. I'm gonna pour it over the table though.
I'm sorry, that's my fault. Oh, okay. Here. And now I'll just grab. Can I just grab this?
Yeah, you can do that.
I am. So,
Whoever's watching is probably gonna get seasick.
yeah, sorry. Let's try up, down, down, left. There we go.
Anyway. There you go.
There we go.
Hold on.
Right. You ready?
Now, real quick,
Wait. Why am I so bad?
the sugar was dissolving. What kind of a substance is sugar? It's polar. Very good. It's polar. Now, what about table salt?
Polar.
Not quite polar.
On. It's no.
Not non-polar.
Oh,
Ionic. Yes, this is an ionic compound. It's a mix of positively charged. So did you stir it already? I think I missed it.
No.
Okay. Yeah, you go ahead and stir it.
There.
Sugar.
Dissolving is faster or slower than the sugar?
It looks like
Curious.
very fast.
Yeah, it
Is
seems
it
faster,
better?
doesn't it?
Okay.
Now, of course, if we were being really scientific about this, what's a possible source of error?
There's sugar and
Yeah, they're using the sugar spoon
So that,
because I only provided 2 spoons, so it was bound to happen. But I'm not concerned.
Last.
Yeah, I guess it's the
That's not on correctly. By the way, future references, I have a laser plan.
nice. If there's ever like a cat that runs into the room, I can go back. Okay, what's the next one? I actually can't remember. I think this one is just a little bit of, okay, canola oil. If you could, does it say how much to measure in? Oh, half a teaspoon. What do you know? I'm just putting olive oil. Okay, it doesn't really matter. I guess. Let's do the, and is that one canola or vegetable? That might be canola. Okay, cool. All right, so I'm gonna, this will be a little trickier. Give it less than half a teaspoon so it doesn't spill and just like that. Here you go. And then maybe great jar. These are the more interesting to see.
Oh, right. I don't like this olive oil. I'm not close up with it.
Just know the difference between like sea salt and non-sea salt.
liqueur.
It's-
Oh,
I saw a really funny meme of Himalayan pink salt. You can go ahead and do one.
they're mixing together. Look
Yeah,
at that.
Did they mix it or?
Oh,
Yeah, go ahead and stir it.
We mixed it together.
How's it behaving?
well.
Oh, that's pretty cool. Yeah,
Wow, they're all exactly.
they're all little beads, pretty much. You can pass that one around. Maybe pass it with a spoon so different people can stir it. And finally, well, not finally. Thank you very much. Olive oil, if you could come up. If you want to do the jar one with the oil. What was I starting to say? I can't remember. Maybe it wasn't important. Yeah, it was really good. All right.
Half teaspoon. Wait, we need.
Yeah, that's good. Thanks everyone for being the hands of this. Oh yeah, yeah. Now you can start. That's a good angle for that. Yeah. And it's great because like no matter how much you stir it, it'll never like fully mix.
Yeah.
It's cool because all the you see how the oil is all in the middle of the whirlpool, right? Now it's separating out. Maybe get a side shot too, so you can see there's a layer of oil on top. Yeah, look at that. And it's beating on the spoon. Very good. Okay. Well done. Now the last one, and I think this one is actually pouring the one oil together, right? So I just realized it'd be better if instead of using that jar, you just use the jar that already has a little olive oil in it. And how much of that does it say? But it doesn't probably matter very much. Okay, then you guys want to take this one and then take that and bring it up here. I don't really care how much you put in, as long as you don't put like the whole thing in. It doesn't really need to be that much though. What I was going to say about Himalayan pink salt was someone pointed out like a meme or something about how like on the jar the Himalayan pink salt, it talks about how it's salt that's millions of years old from the Himalayan mountains, and then it's got an expiration date for like that year, and it says like how lucky that this I got this millions of year old salt just in time before in the year it was going to expire. Expiration dates are kind of funny because I mean a lot of the time they're just really not necessary, but you're required to have them anyway. What's that?
Yeah.
Yeah.
Thank you.
It is not. So I would just like double that amount, just put the same amount of the one in as the other. So how's it behaving?
Mixing.
And these are, would you say these are polar, non-polar?
Looks like gel. Like,
These are non-polar.
These are non.
Yeah, that's why they didn't mix with the water.
Yeah, I don't see the difference.
Now, does it look like they're on different layers? Like one of them is above the other?
No, wait.
Or does it look like it's all blended? They're slightly different colors.
It looks like half. One's on top. It looks like one's like on top, but it looks like it's
Is it the darker or the lighter on top? Lighter's on top. So that's probably the canola. And one thing that you can see that's, thank you, kind of cool about this, it sort of looks like little wisps or something. Well, that's not quite right. It almost looks like chunks of ice in it, really, is what it looks like. But I'll go around with this. Tell me what time it is. I can check, but great. So still got some time. But yeah, look at how they're mostly mixed, but they're a little bit separate. You can see the layer differences. Oh, that's not weird. You look at it. It kind of moves like the whole middle point where it's mixing all moves together. It's pretty weird. But this definitely, it's pretty well blended, right? And that's because it's two non-polars. But if you have the polar and the non-polar together, they just really separate. All right. Before we do anything else, I want to, just to make sure we have enough time, go over what's going to be on your test. So when is your test?
next week.
You guys getting a good feel for the rhythm of this class? It kind of makes sense now. I know when you have like a 3-week rhythm, it can be or a 3-class rhythm, it can be disorienting until you get used to it. All right, so stuff on the test. Obviously, your study guide will prepare you. And hopefully at this point, this is test number 4 coming up. You have a pretty good idea of how to prepare for these and what they're like. The vocabulary is as usual, is the underlined words. We have electrolysis, polar molecule, solvent, solute. Make sure you get those 2 straight because that's 2 points lost right there if you mix them up. Cohesion. And we didn't really talk about hard water, but within the remaining time, we can do that. Hard water versus soft water. Real quickly, what is hard water?
Hard water is water like calcium and magnesium.
That's right. Do we have more like hard or soft water here in Tallahassee? I would imagine hard because one of the things they talk about is that hard water will react with soap scum or with soap and makes soap scum. And like if you look at your bathtubs and everything like that, you probably have a lot of soap scum. But in some places you wouldn't. There's a guy in my youth group. He was I told him how I drink green tea every day just because it's supposed to be healthy. And first of all, he told me how Chinese that was, and it's funny because he's Chinese and Singaporean. But anyway, so we kind of have competitions about who is more Asian, sort of. I'm not actually Asian, but I do a lot of Asian things, and I like Asian food, So, but anyway, I even have like the Chinese board game Go and things like that. But that's really fun. But anyway, so he was gonna make some green tea, and then he like texted me that basically it didn't go well, and I was like, what was wrong with it? And he just texts back like sand, and I'm like, oh, I think I know what he means. And it was that have you ever like at the bottom of your tea kettle or like teapot or whether it's electric or like when we put it on the stove, like it'll get this weird like gray sediment in it. That's a mixture of the stuff that is actually in our water. And when you boil it, remember the water vapor escapes, but just like if you're boiling salt water and the salt remains, like the magnesium, the calcium, whatever else, will actually form a layer at the bottom of your tea kettle or teapot or whatever. And so like whenever we're making tea, we always have to like, I'll swish it around and get it out. Every now and then we'll boil vinegar and water in there to dissolve it and get it out. But I make a lot of tea. I usually have like 2 or 3 cups a day. And so, which is like the only habit I've ever permitted myself. And it was so hard for me to accept having even one habit of tea. But I was like, you know what, I need to.
What's distilled?
So distilled, I really should know that better off the top of my head. I know one thing about when you're distilling water is like, so one of the things is in water is chlorine. And if you I know this just from having fish tanks, if you put the water directly from the tap into the fish tank, like if the fish is just swimming in tap water, it's gonna die. A lot of people make that mistake. Actually, they'll just like fill up a fish tank and put the fish directly in, it'll die. The reason is because they can't handle the chlorine. And so if you, I think distilling water may be more complex than this, but part of it is just getting the chlorine out. And if you let the water sit for 24 hours, the chlorine is gone by then. So if you're filling up a fish tank, fill it up the day before, then get your fish. You can also take about maybe 10 or 20%, I can't remember. I think 10%. You can take about 10% of the water in your fish tank and just put in tap water. That won't harm the fish, but more than that, it needs to be like distilled. You can also get like drops that will take the chlorine out immediately. So yeah, I know that's part of it, but there may be more to it than that. Anyone else know anything about what it means for water to be distilled? Okay. So yeah, hard water, basically like when he was complaining about sand in the tea, it wasn't the tea's fault. It was just that his kettle had some stuff. And my parents, like my dad makes like, I don't know, I think he said somewhere between like 6 or 7 cups of tea a day. And so like his teapot, like you can actually shake it and there's like hard chunks of like, it's like rock, you know, that's just developed at the bottom, and you pour it out and it's just like, it comes out in these great big blocks of sediment. So yeah, that's how I know that Tallahassee's water is relatively hard. The soap scum, but mostly just tea. Yeah, that's hard and soft water in a nutshell. Soft water doesn't have all that stuff. You can soften water by adding, what was it, sodium to it to react with the stuff in it. Yeah.
So Texas
Tuesday. Yeah, Tuesday. So next class. Know the chemical formula for water, which you all do, H2O. Know about how chemical formulas work. So they're going to ask you a question that's about experiment 4.1. So you might need to be aware of that. Like, make sure you understand experiment 4.1. All right.
That's not what we did in class, right?
We did not do that one in class. Just read about it though. Understand why liquid is why water is a liquid at room temperature when other similar chemicals are not. Why is it that water is a liquid at room temperature when other things that are similar are not? It's one of the manifestations of the polarity. If you answer polarity, I'm not going to give you full credit. But because of the polarity, water sticks close to itself, which is called hydrogen bonding. Yeah, so hydrogen bonding is the right answer. Any other answer, maybe you'll get partial credit. You know, it's like you say you go to why does water stay a liquid at room temperature when other similar chemicals don't? All right, 2 more minutes, so let me finish this up real quick. Carbon dioxide and carbon monoxide. Let's see. Well, they're just going to ask you to be able to use chemical formulas to like figure out like how many atoms are in a certain molecule. Like its name is like, you know, something crazy like CH18 or something like that. Like, you know, how many carbon atoms are in it, how many hydrogen atoms. Understand these things.
And when they ask that, they want to know that there's 6 carbon and whatever.
Yeah, like 8 carbon because of C8 and
Because when you asked us that question on Tuesday, I thought you meant how many different types of like atoms there was in.
yeah. And be able to, if they tell you how many atoms of a certain type there are in a molecule, be able to say what its chemical formula would be. So if I say there's 18 neon and 5 sodium, which would never happen, I'm sure, then you would need to know that it's like Ne for neon, you know, 18, and then Na for sodium, 5, or whatever I said. So be able to read and understand chemical formulas and create chemical formulas when they tell you how many atoms are in it. Almost done. Be able to explain why water molecules are polar. Know what types of substances water dissolves. That it dissolves polar and ionic, but it won't absorb or dissolve a non-polar. And there's a couple questions about that. There's also a question, at least one question about hard water. So thanks very much. You're here. Thanks so much.